Welcome to Pragim Technologies. I am Venkat. This is part 100 of ASP.NET video series. In this session, we'll discuss about the advantage of using HTTPS over HTTP protocol, how to identify if a specific web application uses HTTPS protocol, how to configure HTTPS instead of HTTP for an ASP.NET web application, what is SSL or Secure Socket Layer and how is it different from HTTPS, who issues service certificates, and can we generate our own test certificates, and finally, what are the performance implications of using HTTPS over HTTP protocol. So what are the advantages of using HTTPS? HTTP stands for Hypertext Transfer Protocol, whereas HTTPS stands for Hypertext Transfer Protocol Secure. As the name suggests, HTTPS is more secure than HTTP. When the web server and the client communicate using HTTP protocol, the messages that are exchanged over the internet between the client and the web server are not encrypted. Anyone can eavesdrop or secretly listen and see the messages that are exchanged between the client and the web server. That's why any sensitive information like passwords, financial transactions should never be done over an HTTP protocol. Most of the banking applications today actually use HTTPS protocol. The messages that are exchanged between the client and the web server using the HTTPS protocol are encrypted and are very secure. Let's look at some of the applications. For example, let me open up Google Chrome browser, for example, and then type in gmail.com. Look at that, Gmail is actually using HTTPS protocol. Why is that? Because to log into Gmail, I have to supply my username and password, which are obviously sensitive information. And I don't want anybody to be secretly listening on the wire that's connecting my machine with Gmail's web server. Okay, so if I fill in my username and password here and click sign in, it's going to transmit my username and password to the Gmail's web server in an encrypted format. So even if somebody listens to the wire that's connecting my machine with Gmail's web server, there's no problem because the message that is being sent over the internet is now encrypted. But whereas information, for example, if I go to any site like google.com, look at that, that is not using HTTPS protocol. If you look at this here, I can't see whether if it is HTTP or HTTPS, but if I copy that URL, open a notepad and paste it there, look at that, it is using HTTP. But on the other hand, for Gmail, look at that, it is using HTTPS protocol. Okay, and another thing to keep in mind is that HTTP by default uses port 80 and HTTPS uses port 443. How to identify this? For example, when we develop ASP.NET web applications, we deploy them to IIS. In IIS, you can configure these port numbers. So let's open IIS. So click on Start, type Run. That opens up the Run window. In the Run window, type iNet Manager, click OK, which should open up IIS. And within IIS, expand the root node, and then expand sites, and then default website. On the default website, click on bindings. So now look at that, HTTP is using port number 80. And then if I click on the add button, I can add HTTPS protocol, and look at that, the port number is 443. So HTTP default port 80, whereas HTTPS it is 443. So another important question, how to identify if the web application that I am accessing is actually using HTTPS protocol over HTTP protocol. There are two clues that we can make use of. One, obviously, in the URL. Look at that, within the URL. If you can't find it, then most likely it is using, I'm using Google Chrome browser. So within Google Chrome browser, if you can't see the name of the protocol, most likely it is an HTTP protocol, because if I copy that, paste it in the notepad, I can see the name of the protocol that is used. Or if it is using HTTPS, it will actually be shown there, HTTPS. Okay, and another clue to find out if a website is using HTTPS is basically, look at that, the lock symbol. Okay, and when I click on that lock symbol, it's going to show me the information about a service certificate. Now, what is this server certificate? What is HTTPS doing basically? HTTP will not encrypt the information that is transmitted between the client and the web server on the internet. whereas HTTPS encrypts the information. So who is doing this encryption and how is this encryption happening? This encryption is actually done by something called a server certificate. A server certificate consists of a public key and a private key. Okay, and we install this server certificates on IIS, Internet Information Services. Okay, so it's going to contain a public and private key. Now, who issues the server certificates, how to generate them, and how to install them on IIS, we're going to talk about them in a later video session. But for now, understand that HTTPS uses something called SSL, actually Secure Socket Layer. Okay, which is nothing but it's a standard technology that uses these server certificates for encryption and decryption for the messages that are being exchanged between the client and the web server. Okay, and these certificates are actually issued by somebody called certificate authority. And there are several certificate authorities today. For example, VeriSign, TWAT. We'll actually talk about them in just a bit. But in the address bar, what I'm trying to say here is when you click on that lock icon, it's going to tell us about the certificate that is used to encrypt the messages that are transmitted between the client and the web server. For example, this certificate is actually issued by somebody called TWAT. So that's the certificate issuing authority. So there are several certificate issuing authorities like TWAT, VeriSign, GeoTrust, Comdo, GoDaddy, etc. Now, if you look at another site, for example, barclays.co.uk. Now look at this. This is general information page. So even if somebody have a look at this information on the internet, if they eavesdrop onto the wire that is connecting my computer and Barclays web server, and if they get hold of this information, that's fine because this is general information. So that's why it's using the HTTP protocol. So if I open up Notepad and type in and paste that there, look at that, it's using HTTP protocol. But on the other hand, when I click on login, the login page, look at that, so it's using HTTPS protocol. And when I click on this lock icon and then click on this connection, look at that, this is being issued, the certificate that is used to encrypt the messages is issued by VeriSign. And look at the encryption key length. The encryption key length is actually 256-bit encryption, whereas Gmail's one, let's find out what is the encryption key length here. It's an 128-bit encryption key length. Okay, so let's go back. So there are two ways to identify if the web application is using HTTPS protocol. One is the browser displays a lock symbol, and the other one in the address bar look for HTTPS instead of HTTP. So how to configure HTTPS instead of HTTP for an ASP.NET web application? Now we usually deploy ASP.NET web applications to the IIS, the web server that's used for ASP.NET web applications. Now the configuration for a web application to use HTTPS or HTTP is usually done in IIS. Okay, and I told you that the encryption and decryption is actually done by server certificates. We need to generate and install those server certificates in IIS and then configure IIS. We'll talk about that in a later video session. So what is Secure Socket Layer and how is it different from HTTPS? HTTPS, actually, if you look at that, it's the Hypertext Transfer Protocol plus the Secure Socket Layer. So SSL, standing for Secure Socket Layer, it's a standard security technology that is used for establishing an encrypted link between a web server and the client browser, so that the data that is sent over the internet can't be read by others. So all the messages that are exchanged between the client and the web server are encrypted. Okay, so basically when a user requests a secure web page, the server generates an encryption key for the user's session and then encrypts the page's data before actually sending a response back to the client. On the client side, the browser uses the same encryption key to decrypt the requested web page and to encrypt new requests sent from that page. SSL uses server certificates for encryption and decryption. So what is an SSL certificate then? An SSL certificate is simply, a public and a private key combination. And an SSL certificate contains a public key and a certificate issuer. So not only can the client use the certificate to communicate with the server, But clients can also verify that the certificate was cryptographically signed by one of the official certificate issuing authorities like VeriSign, Thwart, GeoTrust, Comdo, GoDaddy, etc. For example, if my web browser trusts the VeriSign certificate authority, and if VeriSign signs my SSL certificate, then my browser is inherently trusting the SSL certificate. So who issues these server certificates? Basically, server certificates are issued by an entity called Certificate Authority. And there are several trusted certificate authorities like these, which we just discussed about. So can't we generate our own test certificate? We can. We'll talk about that in just a bit. So the certificate authority, this acts as a clearinghouse to verify the server's identity over the internet. When a browser requests a page over HTTPS, the browser also requests the server certificate and checks it against a list of trusted sites provided by the certificate authority. If the certificate does not match one of the sites already authorized by the user, or if the server certificate does not match with the web address for which it was registered, or if there is any other problem with the server certificate, a warning message is basically displayed, and an example is shown on the slide. For example, when somebody was accessing this PayPal site, there is a problem with the website security certificate. Okay, and this is how it is shown. Now, if we generally get an information like this, then we have to be a little careful as far as the certificate of that site is concerned. Besides providing, now we understood that SSL uses server certificates for encryption and decryption of data that is transmitted between the client and the web server. But besides encryption and decryption, the certificate authority also provides an assurance to users that a website is authentic. Okay, and it is also possible to generate our own server certificates using a tool called makecert.exe, and this tool comes with Visual Studio and can be used from Visual Studio command prompt. So if you go to Start, All Programs, Microsoft Visual Studio 2010, and from within Visual Studio Tools, you should be able to open up Microsoft Visual Studio command prompt. Right click, Run as Administrator, and that should open up Visual Studio command prompt. And from here we can actually use this tool makecert.exe to generate our own server certificates. We'll actually discuss about how to use this tool, generate the server certificate, and install it on the IIS server in the next video session. So finally, what about performance when using HTTPS over HTTP? Obviously, there is some extra processing time that is required for HTTPS for key negotiation. So key negotiation is also termed as SSL handshake. Basically, the handshake allows the server to authenticate itself to the client so that the client trusts the server. On this slide, you can find resources for ASP.NET, C#, and SQL Server interview questions. That's it for today. Thank you for listening. Have a great day.